When it comes to three-note groupings, the most obvious is the one we've seen before, the augmented triad. The augmented triad is symmetrical, with each note a major third away from the other two notes. But it also includes one of the pairs of complementary notes we saw in the last video. If we consider C to be our root note in this augmented triad, the other two notes, E and A flat, are the complementary notes 4 half steps away from C. Notice that it's true no matter which note we choose as the root note. If our root note is E, then A flat and C are complementary notes. If we add the 7 note to the chord, it adds a tritone pair to the already strident augmented triad. By the way, with the exception of the major 7 and a few other chords, in most chords the 7 note is a flat 7. There are 4 different augmented triads. The shape of the augmented triad seems out of step with the other chords, but it plays a bigger role in music than it may first appear. For example, take the whole tone scale. This 6-note scale is normally explained as each note being a whole step apart from the others. Think of the first part of Stevie Wonder's "You Are the Sunshine of My Life." It looks and sounds tricky, but on the circle it's pretty simple. It's just 2 augmented triads back to back. There are 2 whole tone scales possible. Also notice that stacking the triads this way creates 3 sets of tritone pairs, giving the whole tone scale its edgy quality. If we play with our known chord shapes a bit, another pattern emerges with the augmented triads. Here's the major 7 chord. It's 2 1/5 pairs a major third apart. If the root note is A flat, we have the 2 1/5 pairs, A flat, E flat, and C, G. Why does the second 1/5 pair start on the major 3? Looking back to the harmonic overtone series, the major 3 is the next overtone after the 5. Our 1/5 and 3/7 pairs give us a major 7 chord, but the 3/7 pair is also a 1/5 pair. Starting on this pair, what's its 3/7 pair? It's EB. So now we have 3 major chords spelled out by a pair of augmented triads: A flat major 7, C major 7, and E major 7. Shifting this pattern one way or the other gives us all of the major 7 chords. Grouping notes in sets of 3 also presents another pattern. I think of this as the 4 quadrants of the circle. I'll go back to C as the root note. The first quadrant at 12 o'clock is our root note C and its 4 and 5 notes F and G. As we've seen, the 4 and 5 notes are the most consonant with the root. The next quadrant is opposite at 6 o'clock. Here we find the tritone, major 7, and minor 9 notes, F sharp, B, and D flat. These are the 3 most dissonant notes with the root note C. B, the major 7, is the only one in the C scale. The third quadrant is at 3 o'clock, the 6, 2, and 3 notes, A, D, and E. With C as our root note, we're in the key of C, and as we've seen, these 3 notes are the roots of the 3 minor chords in the key. The last quadrant, at 9 o'clock, has the flat 3, flat 6, and flat 7 notes, E flat, A flat, and B flat. These notes are not in the key of C, but the flat 3 and flat 7 notes give us minor 7 and dominant 7 chords, and the flat 6, also known as a flat 13, is often used as an extension, which we'll get to later. But they also happen to be the keys where C is the root note of a minor chord. So the quadrants at 12 o'clock and 6 o'clock are the consonant and dissonant notes. The quadrants at 3 o'clock and 9 o'clock relate to minor chords. If you want to stay in the key of C, your minor chords will start with one of the 3 notes in the 3 o'clock quadrant. But if you want to build minor C chords, you'll be in one of the keys from the 9 o'clock quadrant.